Did you hear about the scarecrow who won the award? He was outstanding in his field. Oh, come on.
Crowd.
I know. Yeah, okay, we're starting it off. But I know it's corny, but this is Indiana, so. And I want you all to be outstanding in the field of service mesh by the time we finish this. Where's the clicker on this? Okay. There we go. Got it. Got it. This is me, Bruce Basil Mathews. I've been doing this since before the abacus existed. And I worked for a bunch of commercial software, proprietary hardware companies. I finally saw the light about 13 years ago when I got involved with OpenStack at the Diablo release. And I never looked back, became involved with Kubernetes at the beta release and became involved service meshes as a result of that. What are we going to talk about today? Well, I'm going to give you a good description of what a service mesh is and the capabilities and services that are contained within it. Then we're going to talk about the architectures of the service meshes and what they, the different types can do and the pluses and minuses of some of them. And then we're going to do a little bit of a comparison because there's some open source versions of things and some commercial packages as well. And then we're going to do some pros and cons, and hopefully we'll get to some questions and answers at the end of it if you have any. Well, let's talk about the service mesh itself. This new configurable infrastructure layer, both virtual and it allows for the inter-process communication of all of the containers within multiple clusters of Kubernetes or you name it, OpenShift stuff. And the whole idea is to make the communications reliable because let's face it, developers are not that disciplined, and you want to have something that enforces all of the disciplines without them having to remember how to do it. And then the service mesh provides a whole bunch of existing capabilities that you need to support the container environment and microservices well. And this gives you the standardized version of being able to implement them for each of the containers in the cluster. Here's some of the capabilities that we're talking about. Service discovery, really important actually. I've got a new application that came in this container. I registered it so I know that that is now available in the service, and it instructs the path between it and the control plane and the network and all those lovely things. Load balancing, I've got more than one of them. I'm going to be able to timeshare between them and share the load, the various services. Encryption, really important because security is now the key to this whole thing working and being maintained well. And of course, authentication and authorization. Can I actually access the container itself or the data in the container, which is more important? And then finally, the support for circuit breaker patterning. And this is something that few people don't have a good understanding of. This really is checking to see if that container itself is able to transmit data in and out. And if it doesn't, it says, hey, I'm not going to send to that path anymore. Now, the key to that is for the developer has to tell it what to do when it can't. But it's a good thing, and we'll talk about that later. Okay, so those are some of the key things. Why would we provide those? It's really to do two things. It's really to allow for the traffic to be shaped to and from each of the containers so that you can guarantee the quality of the service. And that's the key to having all of the telemetry and everything else captured within this service mesh. The circuit breaker patterning, as I said, allows you to say, hey, whoa, don't send to me anymore. Okay, I'm going to send to this other path. Now this new path has come back again. Okay, I'm going to send to both paths through the load balancing algorithms. But those are up to the developer itself. So there are three key methodologies architectures for the existing service meshes that are out there. There's a library approach, compile all of the services into each container, and you send it along to the next container, recompile it into the library into it. It works great until you make a change. Node agent. Each one of the worker nodes has its own agent to do the proxying of all of the inter-process communication. Works great until the agent itself fails. And at that time, you lose communication with all of the containers on that worker node. But fortunately, Kubernetes is self-healing. It says, whoop, an agent failed. I'm going to recreate an agent and voila, you're back up and running. Sidecar approach. I'm actually going to create a secondary container. I'm going to attach it to the first container so they're co-resident. And I'm going to be responsible for all of the inter-process communication. You don't have to worry about an application server, service. That microservice can continue to put application to and from and to keep managing data for the application. All of the inter-process communication is being handled by this sidecar container. And it fails, you lose connectivity to that container. Once again, Kubernetes is self-healing. It will recreate the sidecar container and voila, you're back off and running. Okay, so here's a couple of service meshes that are out there now that I wanted to go into depth on. The library service. As I gave you, there's an example. This all started off from a library, and Twitter made Finagle and Districts and written at Netflix, and they built these libraries into each one of the containers. And as I indicated before, works really great until I need to make a change to one of the containers, then or the library itself. Then I got to pull each container in, recompile it, and redistribute it again. But it was a good start as to what they were trying to do. Second one, node agents, right? There's an agent doing the proxying on each one of the nodes. It handles all of the inter-process communications between them and the pass in and out via the load balancing, et cetera. Works great, once again, until the agent fails, and then you lose communication on that node for a little while until the agent gets recovered. Now, in both cases, in the library case and in the agent case, there's a high chance of transaction data that gets lost in the shuffle of all of that. And so you may lose, you would have to redo transactions again and repost through the original containers up until now. But the sidecar, this is the key. Yes, the sidecar is there. If it fails, the container knows to hold back the data. It's not going to transmit anything. It's going to store it locally until the data pass comes back, and now the sidecar is able to transmit that data. But there's less of a chance of losing data with the sidecar approach. Okay, some of the existing service meshes that are out there and how you can use them. On the left-hand side, these are all open source guys. These are the guys I play around with a lot. Envoy started this whole thing. They are a lightning fast inter-process communication transmitter. And they, Istio, Linkerd, and continuous mesh all use Envoy as the starting point. On the right-hand side, you have commercial packages, right? Console, I think it came from IBM, if I'm not remembering correctly. Kong, which is a proprietary source of their own, thank you, and NGX and several others. So here is an example of the Istio, how it works, the control plane, the data plane. There's a whole lot of information on all of this stuff. I can't go into all of it because it would take way too much time. but you get the idea that they get really complex. Like this is the Linkerd2 version of the thing. It once again has a control plane, data plane, and it uses its own proxy now, rewritten in Rust, as opposed to what had been the Linkerd Java when I started. Is its own beast. It's created its own, and you can do it both in just a control plane or a control plane and a data plane. And if you do it in the control and data plane, it's able to provide all of those services and expand as your clusters expand. Okay, a little bit of comparative data. Just to let you know, the latency on these things, like Envoy, has very low tail time, 99. And Istio uses it. The fact that they all support RPC and HTTP2 and WebSockets and TCP and all of those kind of things make Istio more than Envoy, but Envoy is its still foundation. Then Linkerd2, once again, started off as a Java program, rewritten in Rust and Go, and as a result got really fast. So, and the guys are really good to talk to there as well. And then Kong, of course, has added a whole bunch of stuff. And the fact that they incorporated Luau and Kona and are now doing plugins for AI, it's a big deal now. We're all doing AI in the service meshes themselves. From a visualization standpoint, most of them use the same basic tools, Prometheus along with Grafana, and they have some kind of alerting mechanism in there somewhere. Pros and cons. We went through these before. The advantages and disadvantages of the library. It has to be recompiled. The advantages and disadvantages of node agents. The agent fails, the chance of losing data on that node is pretty high. And then the sidecar, yeah, it's lower than the other two. And it's faster, by the way, because of the co-residence of the sidecar. Okay, now there was a whole bunch of stuff that I didn't have time to tell you about in this because it's really a 90-minute lecture I shoved into 20 minutes, okay? But fear not. I put a book on it. It's free. It's downloadable from here. It's an ebook. And it's 100 pages. It's a light read. And it's got way more information than I was able to just tell you about. So I'm hopeful that you'll take a look-see at that. And as a result, I'll fill in all the blanks that I couldn't fill in from here. Okay? Morantis, they paid for me to come here. They're hiring. Happy Halloween. Love y'all. Any questions? Question? Nay, nay?